بسم الله الرحمن الرحيم والصلاة والسلام على رسول الكريم. Monsieur Dahmani et Monsieur Djabour, en vue de l'obtention du diplôme master, vous avez demain jusqu'à 25 minutes pour exposer votre thème intitulé Realisation and Automation of PV Power Rocket Machine System. تفضل.
Firstly, I would like to thank those of you who are present here today. And I would like to read upon you these two meaningful quotes. The first one by Thomas Edison said, "I put my money on the sun and solar energy. What a source of power. I hope we don't have to wait until oil and coal run out before we tackle that." And Bill Gates said, "Robotics and other combinations will make the world pretty fantastic compared to today." I would like to shed the light on the two words, solar energy and robotics, and present to you our titled Realisation and Automation of a PV-powered rocket launching system. Presented by myself, Jabor Yusuf, and my colleague Thème and supervised by Dr. Zakaria Abdallah. The presentation today contains firstly of an introduction and then followed by the definition of energetic autonomy, and after that the power system and the orientation system, and finally targeting and missile launching and accuracy. Starting with the introduction, we can say that robots have greatly invaded the human lives, becoming an asset in most fields, and continuously pushing humans into their development and their manufacturing. Due to human limitation in terms of energy and ability, the researchers and engineers in this field have been leading the studies that benefit technologies in a way that would enhance and develop or overcome challenges that is in the way of making the human life easier. Integration of the renewable energy sources is the main concern that's being handled right now, nowadays, to enhance the robotic of the energy autonomy. So what is energy autonomy and what is the proposed solutions in our study? As a definition for the energetic autonomy, it refers to the ability of the system to maintain itself in a viable state, meaning that it works successfully and without any failure for a long period of time. Its behavior must be stable, and in order to not yield in an irrecoverable debt in any vital resources. Our system contains two main subsystems. The first is the PV powering system, and the second is the missile orientation subsystem. The PV powering system role is to assure the power electric transfer from the PV panels to the second subsystem, which is the second subsystem is constructed in a way that allows it to position itself in two desired angles in order to reach the target, in order for the missile to reach the target. First, we start with the power system. The power system contains a PV panel which is directly connected to a DC-DC buck converter controlled via an MPPT controller. The DC-DC buck converter then feeds the battery, which will eventually feed the system actuators of the second subsystem.
And now we start with the PV panel. So we have on this line here, we start by proceeding to the PV cell model. So out of many PV representing models, the single line model has been adopted due to its simplicity, and we can say that the following equations demonstrate the PV cell mathematical model. We have the photocurrent, the saturation current, reverse saturation current, and convert the shunt resistor and the output current. And after building the PV cell mathematical model, we have chosen a certain PV panel which has the following characteristics. It has a rated power which is equals to peak power which is equals to 14 watts and 21.24 volts for the open circuit voltage, and short circuit current which is equals to 2.55 amps, and we have it has a number of cells connected in series, 36 cells, and the number of cells connected in parallel, 1 cell. The ideality factor of the diode equals to 1.6, and we have 0.1 ohms for the series resistor and 215.405 ohms for the shunt resistor. At the same slide, we have the next characteristic, which represents the IV curve for generally for any given PV cell. I would like to highlight the main parameters extracted from this figure. We have at 0 volts, we can highlight the short circuit current, and for 0 amps for the PV cell current, we can extract the open circuit voltage. Every cell has maximum power point, which is the coincidence of the optimal voltage and the optimal current. Now, after we build the mathematical model, we proceeded next to the simulation result under software simulation MATLAB. So, the simulation has been achieved according to 2 cases. First, we maintain the temperature, and then we maintain the radiation. By maintaining the temperature, we have these results. This figure represents the PV power variation extracted with respect to different irradiations. And the constant temperature, which is equals to 25 Celsius degrees. It illustrates how sensitive the power is according to different irradiations. A relative the direct proportionality resumes the relation between those 2 parameters. Starting from an irradiation from 0 watt per meter square up to 1,250 watt per meter square, an amount of power is produced from 8 watts to 15 watts respectively. For each curve, we can remark that the power is increasing from 0 to reach its maximum power point, then decreasing again to be equal to 0 at the open circuit voltage. And likely, we can remark that the open circuit voltage is slightly variant with considerable irradiation variation. On the following curve, we have the IV curve. So we can see that the short circuit maximum values increases each time the radiation increases. Then the PV cell current remains constant, except a very slight ignorable decreases. Being over the optimal voltage, we see that this current decreases or takes a very fast decreasing behavior to reach 0 amps with open circuit voltage. Mostly, we can say on the next figure that with maintaining the radiation constant, which is equals to 1,000 watt per meter square, we can put the mark that the open circuit voltage here has a large band variation, unlikely the case where we maintain the temperature. And for the IV curve, we remark that the open circuit voltage has also great variation with respect to temperature. And now, after obtaining the PV panel characteristics, we pass to the MPPT algorithm and buck converter. So, in this study, a buck converter has been chosen due to its simplicity. Simply, a DC converter is a topology which consists of a controlled electronic switch, which is in our case a MOSFET, and the non-controlled electronic switch, which is a diode. An inductor is used to store and release the energy to the load. The capacitor is used to filter and smooth the output voltage. On the same slide, we have the chosen buck converter parameters, the inductor value, capacitor, load, which is purely resistive to the frequency and the current and voltage ripples. And now we proceed to the perturb and observe MPPT algorithm. We have on this script MATLAB code which controls the buck converter. We have the defined function, which has as inputs the voltage. Okay. Next, we have the simulated block. From left to right, we have the solar panel, which is directly connected to the PV buck converter. This buck converter is controlled by the perturbed observed MPPT algorithm, which generates the desired duty cycle. This buck converter feeds directly a purely resistive load. The irradiation input, which affects our PV panel, has the following form. It is a scalar form. And now we proceed to the important point of this PV system. The simulation results as next. The blue curve represents the ideal theoretical power extracted from the PV cell without MPPT algorithm. And the green curve represents the power curve extracted.
The PV power system feeds directly the orientation system. There are many ways to model a robot. But amongst the literature, there is one highlighted way. It's called the Denver-Hartenberg. The Denver-Hartenberg is relatively uncomplicated when it comes to the process of obtaining the direct and inverse kinematics, which brings us to this one. The direct kinematics were also. Kinematic equations of the robot to determine or compute the position of the end effector from specified values of the joint parameters. The use of the Denver-Hartenberg convention yields the leaf transformation matrix shown, which is also shown in the thesis. In the robot characteristic, the simulated robotic arm is characterized by the following parameters. Mechanical articulated structure. Its mechanical articulated structure is a serial manipulator. It has two degrees of freedom. Its type of joints is revolute, and it has a rotation range of the first joint, 360 and 90 degrees for the second joint. With the previous characteristic table in mind, we obtain the following DH parameter. Once the parameters are applied, a basic model of the robotic arm and frame joint are structured accordingly. The following figures represent the robot links and joints. The first matrix shown in the table demonstrates the transformation matrix of the first frame with respect to the base frame. The second transformation matrix represents the transformation matrix of the second frame with respect to the first frame. And finally, the third transformation matrix is the transformation matrix of the second frame with respect to the base frame. Therefore, the joint values and position the figures represent from left to right the end effector position with respect to the base frame and the joint values evolution in time. As you can see, it's all the values are gradually and in sync evolutionary in time, and the negative values represent the clockwise direction of the movement. Here is a demonstration of an animation of the workspace that can be used with the robot. The robot will attempt to turn 10 turns while targeting up to 90 degrees.
And now we proceed to the targeting and missile motion. To plot the motion of the missile, we've used a MATLAB code script, which is described on the following figure. So all those equations are abstract physical equations, which are put here on this MATLAB code, and this code generates these results here. So we have a Cartesian coordinates frame. We have a desired target, which should be reached by the projectile. So we conclude that the implemented MATLAB code works as well as good because it reaches its position. And now with the conclusion, we can say that the implementation of the MPPT algorithm on the PV system has provided a close result to the ideal theoretical power, expanding the efficiency of the power outage, hence providing more power to either use directly or store, which will enhance the energy autonomy of the system. Based on the simulation of the robotic arm, the data Hartenberg parameters with chosen angle values had proven that both of the first and second joints are correctly structured as desired and to obtain the wanted orientation of the held missile. Concerning the missile motion, the simulation results has proven that it's sufficient to know the target coordinates to obtain the first joint volume. Knowing the initial velocity of the missile is needed to determine the right joint volume of the second joint. With the two joint values, the position of the missile holder can be assured using the transformation matrix. As a conclusion, and based on what's previously stated, the aim of this study has been fulfilled with respect to the firstly outlined goals. Thank you for your attention.
Bon, je tiens à vous remercier pour l'exposé. Son table de jeu parce qu'elle a parlé directement contre le examinateur, monsieur.
Thank you, Mr. Chairman. Thank you very much for your presentation. Actually, I like to know English. It was very nice. It was very encouraging for the other students if they are here, but unfortunately no one is here to see that. Well, the subject is a very important subject. It's a very, very nice subject. And I see that the subject is composed of two parts.
Yes.
And each part actually, honestly, is very heavy part. Both of them are heavy parts. So I was wondering when I saw the title, how could they manage to make all this in this thesis? Well, it was the nice part of my intervention. Now let's see the other side. Firstly, I was looking to the first chapter. It was, no, I think first or second. It was talking about robots and so on.
Yes.
I don't feel that this part is very linked to what you have done. I mean, robotics is very, very, very huge field. So, but I was looking here and reading some of this movement and others, and I was trying to find the link with your system. Is it very linked to your system?
So the very first chapter is generalities about robotics.
Yeah, I know. I can understand you. But even when you make generalities on something, try to be focusing on a part of it. Because if you talk about robotics, it's infinite world.
Due to the huge universe of robotics, we have to focus our attention on the kinematic part of the robotics. So we studied the kinematic.
Excuse me for this. Kinematic is for all robots. So we are not focusing on something. But even kinematics, what do you mean by kinematics? All of them are kinematics.
Yes, are you asking us what type of robot?
I'm asking, I feel that it's necessary to talk about all this.
Okay, let me clear a point here. You want to observe the link between robotics and our subject?
No.
So, I'm sorry, I'm not following.
No. You're talking about a very, very, very large field.
Yes.
I mean, if you have focused on part of robotics, I mean, you talk about robotics and then you focus on special parts. What kind of robotics you're going to study?
Yeah. We mentioned that on the presentation. If we didn't do these generalities, we couldn't classify our robot. Which range it is classified?
And
I
our
think you
robot is
respond.
classified under the signal manipulated robot.
Yes. So without these details, we can't classify our robot.
Okay.
The mechanical structure. Like if I give you directly the chosen robot here in our study, you won't get the point where it is, what range it is put this robot here.
Yeah.
So it is a serial mechanical structure with 2 degrees of freedom.
Unfortunately, due to the actual situation, you didn't make realization, right? You didn't realize the system.
Yes.
But for this point,
Actually, we've done our possible to make the realization finished, but due to this pandemic situation here, we've bought some components, but time was very limited and still needed some components like
I can understand this. This happened to all the students.
Yeah, unfortunately.
But yeah, in this context, because I will start from the last line. As a conclusion, and based on what previous studies, the aim of this study has been fulfilled. Do you think the aim of this study has been fulfilled?
But you have to continue the sentence.
With
respect to the first outline goals, and you have to first.
What are the first of the?
So we had to ensure an intelligent extraction from the PV panels to the actuators of the robot, then orientation them to the desired position in order to reach.
Wait. For this, I didn't see power or setting up. I didn't see it. Where is it? I mean, where is what you are seeing now in your thesis? Show me page. I would like to see it.
So the first
Page
59.
Huh?
Page 59.
59.
This is the first point.
58 and 50.
Yes.
Okay. You have the comparison figure.
Yeah, but what is this?
It's the comparison between the theoretical power and the algorithm power.
Are you powering the system with the PV directly?
No, we have the store.
No, yes.
No.
Wait, let's start with you.
Yes,
Why yes?
we are powering the system through a power converter that's controlled with an MPPT algorithm.
Okay, then the energy.
Why no? He said yes because.
We are not the same way, but I have to explain to make my point.
So did you calculate your motor power because it is motors?
Firstly, we calculated the power with
There's 2 stepper motors.
yes.
And the rated power needed was around 40 watts. What? 40 watts.
40 watts?
Yes,
That's all?
for each one.
Are you sure about this?
Yes.
So it's very small missile.
Yeah, it's prototype. It's prototype, not the real one.
The missile that we based our study on was it's called the spike technique.
Actually, it's missile, not missile. They say missile and missile.
Okay, doesn't matter.
Missile. The missile that we based our model it was called spike technique, and it's around a kilo or so. It's a guided missiles that targets tanks.
Yeah, it has a small size, around I think 50 centimeters.
So it's not really.
Yeah, but it is used in the Iraq war, for example. It is constructed in Israeli inventors. They made this rocket.
Look, generally in these kinds, they use hybrids. They don't use parts alone.
They
Hybrid system. You know what's hybrid?
Yeah.
I mean, they use human power with solar power with other kinds of
Yes.
things.
The missile does use hybrid energy, but the larger, however, the larger could be powered using electricity.
Yeah,
of course, but I mean the source, not the power used, the source.
The source of the launching system.
Yeah.
Yeah.
What is the launching system?
The launching system is a system, as we say, is a robotic arm.
Look, the launching system doesn't control the orientation.
Yes.
So it carries motors.
Yes.
And motors need energy. And the energy is calculated based on what?
Based on the choosing stepper motors.
No. I mean, even the stepper motors are chosen based on what?
Based on the torque.
The torque.
They can handle, yes.
Yeah. Do you know the real torque of missiles or the system?
The real torque.
Yeah, of course. Do you have data or just you were imagining the system?
We had data at first, but when we canceled the realization, we didn't see the need to put it in the thesis.
I think it's very important to put it because you're making design, and design you need data, or at least put your data. But without data, how are you going to make your?
That's true.
We did use the data, but we didn't put it in the thesis.
And that's due to we canceled the realization part, so we didn't see the need to put that. That's why.
Okay. Now back to your system. So it's solar panel feeding the back converter, and the back converter is feeding the motors.
No. Feeding the battery, you have the storage part here.
Well. I'm putting the schematic of it. Because you're talking about PV panel feeding the motors. This is what you have said.
You followed my presentation.
Yeah, because I was saying in my question, what is the need of batteries here? So you're not feeding the motor, you're feeding the battery.
Not directly, yeah. The battery is
directly
the energy, yeah.
Directly the battery.
Then we have to feed our actuators, robot actuators, from the battery.
From the battery.
Yes.
Not from the PV.
Yes. And we mentioned that. It is actually a representation.
I asked a question and you say no, yes, and I was waiting this answer.
It's just a misunderstanding.
Yeah. We are all the same in the time.
Okay. Page 59. Well, I didn't speak about the form and the others. Well, I feel because I didn't read it from paper, I read it from my screen. I feel it was a good book. I feel because I turned some pages with inside. Well,
That's another.
except some figures now, some equations. It was like copy and paste. Yeah, it was copy and paste.
I have written every single equation.
Yeah, I don't know. Maybe on my screen it was very faded, not clean one.
Okay, maybe the font and the size of letters.
I can assure you that I have spent hours.
Okay, I believe. Yeah, 59?
Yes.
Now this figure, 51.
51?
Can you explain it again?
51?
Yeah, because I see a lot of swinging before.
Sir, 51 or 59?
51. No, page 59, figure 51.
Okay. So, what's the question?
Yeah, can you explain it again?
Okay. The blue curve represents the ideal.
Okay.
And how we can judge the MPT efficiency, perturb and observe?
Okay.
By comparison to the ideal theoretical part.
Okay.
Putting them together, we have these results.
Yeah, but why we have this swinging in the first part, and when you put another steps, we don't have any swinging?
So the reason of the oscillation.
Yes, please.
The reason of the oscillation.
Go ahead.
The reason of the oscillation is because of the initial value of the set.
No.
Yeah, continue.
And also the step iteration. It was a bit small.
Step iteration.
Of the set.
Okay.
It was a bit small. The reason there are no oscillations in the second and third bumps because the difference between the irradiation value was not that big.
Look, if you are talking about step iteration, you should put this aside.
Not step iteration, not step iteration. The step in algorithm.
Yes.
The step in algorithm.
We have.
It's not step of iteration, step of either of duty cycle. You perceive the beyond duty cycle.
That is what I said.
And is the target. And when he reached the ppm,
Okay.
it's there is no oscillation.
Yeah, it affects the behavior if it will be slow or fast. This is step into the cycle.
Yeah, in this case you need to put this alone and the other one alone. I mean, you should overpass this part to tell us that it can respond in this way with different steps. But like this, I see that this response is not the other. So this is why I was wondering why it is not the same. This is the first, for me, as automation.
Yeah.
I can say this is the first order system and this one is something like third order system. It is the third order system.
Can you let me respond in this point? Can you let me respond in this point? In direction, and he made a step in another direction. You know?
Sir, should I clear you something here? These oscillations are due to this one. This one here.
Yes.
Then you have to refer it to the cycle of this module, each iteration.
Okay. The angle of iteration, not the iteration of simulation.
This is why I said you needed to overpass this part because it's not transient due to the system, but due to the algorithm.
Yes.
You should put it aside, then take different steps because the other steps are very small, and then take different steps which are really clear.
Yes.
Then I can see that, oh yeah, it is the first order system. But in this case, I believe you.
Yeah.
But I needed an explanation for this. Because in the first part, I see third order system, then it becomes first order system. Something happened inside. Okay?
We should to note that in the final version of the decision.
Okay.
We should to add it.
Yeah. Okay. How many motors you have in your section?
What?
How many motors?
Motors?
Two motors.
Because we have the robot has two degrees of freedoms.
Did you talk about the control of these motors? The controlling system of these motors?
Actually, if we proceeded to the realization.
Yeah, I know, I understand you.
Yeah.
But at least you have a vision of your system.
Yeah, we have.
I mean, you should write it your vision because the point that you're not talking about, in this case, you should stop in the not first part. PV powered rocket, and you don't talk about automation.
I got you.
When you talk about automation, you should tell us about the chain that you are proceeding to activate your motors. And how do you calculate the signal? I mean, the signal that gives you the precise, the accurate angle.
The PWM signal generated from.
And where do you copy? When do you get your coordination?
Coordination
From
the user.
The targeting algorithm that's being simulated.
The user has to tell us what's the coordinates on the Cartesian frame.
This is the true answer. The other one was out of the way.
I was about to get to that. If you go to the Alex.
This simulation, did you maybe make it yourself or you found it in MATLAB?
We made it by ourselves.
Actually, was going to do a simulation in MATLAB, but the toolbox didn't work on the correct.
And this is MATLAB or
no, this is a software called Robo Analyzer.
Okay, so you didn't make the graphics. Everything was there.
Yeah.
Everything was done. Now, about the coordination.
Yes.
What kind of coordination you use?
Cartesian coordinate system.
What is it?
Cartesian.
Cartesian.
Yeah.
Okay. Cartesian system.
Yes.
You mean
X and
X,
Y,
Y,
Z.
Z.
Yes.
Is it enough?
I think it is.
Are you sure it's not? You know that X, Y, and Z, we use it for translation.
Yes.
And we don't have translation.
But it is sufficient to represent a 3D object on the space. And our target is generally on the ground.
We are not talking about the target. We're talking about your motors.
Okay.
They are controlling the angles.
Yes, that's exactly. That's
How many angles are you controlling? 2 or 3 or 1?
Two joints, revolute joints, not
transition. If you may let me speak. The modeling of the robot was modeled with the Département method, which works with the linked transformation matrices.
Okay?
The linked transformation matrices have data about the transition and the rotation of an object in each joint.
You're talking about the object. I'm talking about the legend.
yeah.
I'm saying in each joint has a Cartesian frame. Do you get what I'm saying?
No.
So, if you look closely at the if you look closely at the models in page 62,
You can see that every joint is assigned with a Cartesian coordinate system, X, Y, and Z. And then we have to do the direct kinematics of the robot. We have to get first the transformation. Right.
I'm controlling motors.
Yes.
Motors are doing rotation. I need angles.
yes,
You're controlling a step motor. Give me the angle. You don't give me the angle. You give me the object coordination. So I'm asking about the angle. Theta and phi.
Yeah. Theta 1 and theta 2.
Theta 1, theta 2.
yes.
Yeah.
Okay. Did you give me the theta here? In this?
We've done initially
In the simulation,
The equation motion.
simulation. Yeah. Equation motion.
the client or the user will put the coordinates of the target.
And then
And the coordinate is based on the base frame of the robot. You get what I'm saying? So in the base of the robot.
For me, I need theta 1 and theta 2.
yes.
That's all.
If you need
Did
this.
you mean
calculate it?
Did you mean here?
Yeah, we made it.
Give me the equation.
Okay. So if
Maybe
you go to the annex, page 69.
So,
If you go to page 69, there is the algorithm that calculates the angle.
69.
Yes.
69. No.
Okay.
No, I don't agree with you. I don't agree with you. Don't give me my algorithm. Algorithm is based on equations.
Yes.
Where is the equation of
That's
the
the second chapter.
Okay.
I just wanted
You needed to go after it. I don't need the
okay.
The algorithm is just an implementation of the
Equations.
Where page I
Okay.
should see that?
All right. Page 14.
Starting from page 45.
56.
45.
Yeah.
Okay.
Take the decision. 46.
46. Right.
Why there is no difference?
Okay.
46? Oh no, 36.
Okay.
40. Okay.
This is a whole mathematical proceeding.
Yeah.
Given the coordinates of the target, we get the joint's value theta 1 and theta 2, which will be then given to the robot, which will use the Dinavit-Hartenberg convention to position itself to the desired position.
The equation you are looking for is equation 54
Yeah.
at page 49. Excuse me for the
49.
mistake. Yes.
Page 49, equation 54.
Where is theta 2?
Yes, theta 1 is.
I can see theta 1. Where is theta 2?
Okay, theta 2 is in page 50, the equations 56 and 57.
Yeah, I forgot to put 2, just under the theta. It's a mistake.
57, that's what. 57, are you sure?
I said the page 50 and the equations 56 and 57.
Ah,
Yes.
50 equation.
56 and 57.
Yeah.
The equations.
Theta 2, but here just there's a mistake and you can see 2.
Okay, this is theta. Is this theta 2?
Yes.
So,
Yeah. Yeah. We will. This is just a mistake of text.
yeah, because I was looking for it.
Yeah.
I didn't find it. So, okay.
We will correct it.
Okay. I have a lot of questions, but my colleagues now are urging me to say thank you very much for your presentation. It would be very nice if you have made it, but unfortunately I can understand the situation. Thank you again. Thank you, Mr. Chairman. And
Moi, je tiens à vous remercier, monsieur Ahmed. Donc, je passe la parole au deuxième examinateur, monsieur Taïfan.
Thank you, Mr. Chairman. I thank you also our student Ahmed and Jabor for the quality of your presentation. Okay. Let me say that I am very happy to see our students use English language in their research activities. Okay. I have a strong question and some remarks. I cut with the remarks. It's a very heavy subject with short introduction. Okay? You don't present the problem and the details of your chapter. Okay? The first question, in the page 3. Page 3. Could you explain me these new words?
What are these words?
Page 3.
Yeah. Where exactly?
Okay? In the first paragraph.
Okay.
Present the recent development.
Okay.
Please.
Allow me to start it. Recent development in robotic words has made
Recent development. 2. I have new words for me.
Yeah.
Paragraph 1. Affordable.
Word? Affordable. That means share.
affordable?
It's not expensive.
Yeah.
Affordable is the opposite.
Yes.
Okay, yeah.
More.
Affordable, c'est.
Moins coûteuse. Moins coûteuse.
Plus optimal ou non.
Affordable, ça
Plus coûteuse.
And I have new words, hazardous environment.
Hazardous, that means
Random.
Yeah, okay. My second question. In the same page, you spoke about motivation. You said that you participate in the CIAA preparatory competition.
Yes.
Could you tell me about this competition? And my second question, is it the same rocket?
It is no.
No, okay.
So the competition was
universities. It's inter-university competition here, but those 3 top classified will go to the United States in order to compete to represent Algeria in let's say this international competition at the USA, New Mexico. But we get the 6th place by the way among 12 universities.
Okay. I think that you participate in Liga.
Yes.
Could you tell me about this competition?
Okay. It was, we were asked to make a rocket and the satellite prototype. And we, the electrotechnical students, we were charged to make the satellite PV feeding. But unfortunately, there were no supply, but we couldn't do it.
couldn't get the small cells to fit into a cell.
Okay. In the page 22, in the conclusion, in the first paragraph, page 22.
Okay.
The first paragraph. In the conclusion, in the chapter, we have denoted the definition of some technical terms and the review of literature related to the field of model, identification, and control of robots. Is it true?
We will frequently come across these terms in this thesis, and some of them will be reformulated in a more analytic or mathematical way.
Is it true? You speak about model and identification and control of robots?
That's not actually.
I didn't see this model and identification.
No, we explained the models of the types of robots, the mechanical models, the mechanical modeling. I mean these.
Classification of robots.
Not identification and
So
control.
this is
Not changed.
yeah, we have to correct it.
In page 4, robots. Page 4. Robot.
Your
Robot is
Zakaria, you're not.
in page 4. Robot is okay. We must have the conclusion of the chapter 1.
Okay, what was your point? Conclusion. Okay.
Okay. Page 4.
Page 4.
Okay. Robot.
Yes.
Part 3, part 2, robot.
Yeah.
You say that robot is a mechanical device. I think it's a mechanical device.
Yes.
Generally.
Yes.
Yeah, that's the general case, but you can find.
Robot, it's a mechanical device, not.
Yeah, but you can find in manufacture a pure mechanical robot. There is no electrical components.
Could you give me one example?
For example,
For example, Google.
Yeah.
It is a robot. That's
It's a
very
robot, but
yes.
it's a mechanical. It's not a mechanical robot.
yeah.
I think that.
But this definition, I think, is too
I think
full.
essentially
Yeah.
the robotic field is a part of the mechatronics field. Yes?
Yeah.
Okay. And in the same paragraph, robot is a mechanical device, contain electrical, X-ray, and IT
Yeah.
parts.
Yeah.
What IT?
Information and technology parts, which has sensing
You should have it.
data up.
You should have it.
The word device is not very clear, actually. The word device.
What's the accurate one?
Device is system, let's say system. But device is like
Compound.
parts.
Yes.
It's not really a device. When we talk about device, we talk about many devices in that part, but we don't have many devices. It's like
Actually, what?
The next page, page 5. Not yes, page 5. And page 4. Monitor type. We speak about page 4 and page 5.
Page 4 and
The
5.
part 3.1, the word joint. Why is not this first paragraph by this limit?
Yeah, this
You
returns to.
can't start a new paragraph with this.
Okay.
It's the same error in the next page. Please make it joint. I can't pronounce it correctly.
Yeah, it's a joint. Yeah, revolution joint.
Okay. Okay. Page 28.
28.
28. Equivalent model of TV.
Yeah, single line.
Okay. Can you explain this figure? Dot and why use this model?
Yeah, due to its simplicity, it is simple to complex. So we wanted to proceed with this model in order to make it just easy. Why taking one model which is complicated just to obtain the PV cell characteristics? So we could do it just with this model.
In the page 37.
What's it?
37.
27.
Sorry, 27 or 57?
It said 30, 37.
37.
Yeah.
37. 37.
Yeah.
To supply levels, you must use everything algorithm.
Yes.
Okay? External power, internal power.
Yeah.
Okay?
Yeah.
You give flow shots. Okay?
No, so which page?
Page from 37 to 39.
From 37 to 39.
Okay?
Okay, the flow chart, yeah. That would be the inverter observer argument.
Can you explain me this flow chart?
Yeah.
Okay?
We have as inputs the PV panel voltage and the PV panel current. Then we have to calculate, we have to
compare the power in the current time and the following time. If the power increases, we will check for the voltage. If the voltage increases, then we will add an iteration to the duty cycle. If the voltage decreases, then we will add a negative value to the duty cycle. And if the power decreases, we will also check for the voltage. If it increases, we reverse it.
How do you do that?
by control.
Yeah, of course, by a controller. But how do you do that?
How do you do what?
With sensors.
Playing on the
Current
duty
sensors
cycle.
and the voltage sensors.
No. How do you play on the duty cycle?
The duty cycle using the PWM. So
Practically,
Do you know that you need a regulator inside?
Regulator to regulate what?
How the duty cycle? The duty cycle you cannot control it like this. You need a regulator inside. The PI
feedback.
Yeah, feedback with PI at least.
Regulate.
Huh?
we use that and microprocessor and the
It is inside the microprocessor.
Okay, so you have to.
Okay, I need to discuss with your supervisor. But what I said was true. I work on this.
We think that the climatic conditions can affect the output.
climatic conditions, yes.
Yeah.
So the PO algorithm extract the maximum power in certain climatic conditions.
Whatever the radiation, either the temperature, this algorithm here assures the extraction from the panel the optimal voltage by imposing the right or the perfect impedance into its limits.
Okay. In page 35, the presentation of an object in 3D space. Page 14.
14, okay.
40.
Yes.
40, not 40. Okay. Figure 36.
Okay.
Okay. In this paragraph, we say that the independent paragraph determine the orientation of the solid around the point P. Where is the point P?
It's the best center of the 3D object. Just we forget to point it.
But where is the point P in our field?
Yeah, that's another consideration.
point P is Euler angles, and they was really expecting you to talk about Euler angles.
Yeah, but we choose the Cartesian coordinates, so we don't have to. We didn't want to make it more complex.
No, with Euler is very, very simple. Euler angles is very simple.
Then we had to take another supplementary courses for robotics.
Now, did you work on this point P?
What?
This point P, did you work on it? Did you use it? This point P?
No,
If you have used it, so you need Euler angles. It is written in your manuscript.
Yeah, but this manuscript is taken from a book, a robotic book. So.
In the same page, the presentation of the position. In the same page, the presentation of the position. Of what?
Position.
Of what?
Of certain point of the space. Okay.
Where? After position.
Okay.
Okay. For page 45.
45.
45.
Yes.
Okay. The figure 40. It's very easy figure. I have made I saw this here. And
it's a representative figure of the coordinates of the missile based on the base frame of the robot. So if you can see where we have pointed the first angle, the theta 1 and theta 2, there is where the robot should stand.
what is power?
It's like that.
Okay.
Theta 2 make this orientation.
Okay. Okay. Continue.
Yeah, as you said, you have to know that the robot base frame coordinate system is coincident with the coordinate system of the target. They have the same point O, the origin O.
You can imagine it as the missile flying from coordinate.
Can you imagine?
I'm trying to explain that.
What did you say?
I said you can imagine that the missile is moving from point A, which is the missile launcher,
Okay.
and which is the center of the Cartesian coordinate system, and flying to the target in a projectile motion.
In the next page 46, acceleration.
Yes, we
Okay. In a paragraph, in the projectile, okay? In the projectile 2, in the vertical direction. Okay?
Yeah.
Okay? Could you explain this paragraph using figure 5?
Figure what?
In the projectile motion, there is only acceleration in the vertical direction.
Yes.
Yeah.
Okay?
If we ignore air resistance and all the other.
I want to explain this paragraph according to the figure 5.
The missile actually is affected by the gravity, which is the acceleration g, which is equals to 9.81. On every point of its trajectory, it is affected by the acceleration, which is always vertical on the xy plane.
Not the vertical.
No, it is acceleration.
Vertical.
Acceleration, not the motion. Acceleration in physics, when you represent the gravity, it is always vertical on the xy frame.
The missile is affected. The missile is
Can you
affected.
repeat, please?
Yeah, I said that.
I hear you very well.
For example, here we have a car walking at the street. If we want to represent the gravity,
Okay.
we should look first at the center mass of this vehicle. Then we have to design a vector vertical to the xy plane at every point of its trajectory.
And in a missile, it is the forces applied on the main forces, is the force that making its velocity, and the acceleration is at every point bringing it down to the ground, which is the acceleration due to gravity. And the acceleration due to gravity is only vertical. There is no acceleration due to gravity in the horizontal plane.
Okay. For the page 47, question 43, type of light.
43.
Yes.
Yeah.
Yes. The type.
Represent type of light, TF, equal to 4.
Yes. 2.
V0. Yeah. That's it.
Yes.
Okay?
Yes.
You know that sin of 2 is between
Minus
-1
1
and
and 1.
Yes.
Okay. TF can be negative.
No, but time is considered as absolute only. We have the absolute value of time.
But here, you should give range of value of
Absolute value, yeah.
you,
Okay, that's really good.
okay?
Yeah.
I have a lot of questions, but I think it's
Bon, je tiens à vous remercier, M. Demi. Donc, avant de passer la parole au cadre, quoique j'ai reçu le point de vue comme à la même minute, mais cela ne m'empêche pas donc, de poser quelques questions. Donc, comme vous savez, donc, un travail normalement, on a deux côtés, il y a le côté faux, côté là. On a donc tout commencé. Donc, je dois donc vous saluer donc, pour l'initiative, la première initiative, c'est-à-dire de travail en anglais, donc sur l'innovation, donc pour la futureuse, donc promotion, donc de songer donc, à la révision en anglais, à exposer en anglais, avec la première initiative. Donc, concernant votre travail, là, on parle de réalisation. Mais je suis réalisation, c'est une simulation. Donc, il faut carrément changer parce que il y a une grande différence entre simulation et donc, réalisation. C'est vrai. Donc, c'est pas facile de réaliser ça, mais c'est une simulation.
Au début, c'était ce qui pensait
C'est aussi que vous avez songé à faire une réalisation. D'accord? Mais ce que vous avez fait, c'est que vous avez présenté une simulation. Donc, il faut carrément changer le thème, le sujet d'un thème.
C'est une directive du département. C'est les directives du département de changer tout.
Non, mais c'est bon, je ne suis pas content. Je ne suis pas content, mais ça empêche que ce que vous avez fait, c'est une simulation. Donc, il faut changer, changer le titre. Avec première chose. Donc, je reviens donc à votre manuscrit. Maintenant, vous avez donc un manuscrit. Première page, c'est une introduction générale, donc il faut différencier. Ce n'est pas introduction. Il m'a dit que c'est un résumé dans mon résumé, ça, c'est une introduction générale. Et si c'est un épée, si c'est une introduction générale, elle est incomplète. Parce que ça. Donc, une introduction générale, on doit présenter notre travail.
Mais nous, quand on faisait notre recherche dans la littérature anglaise, on trouvait le titre de l'introduction générale, c'est mon introduction. Il n'y a pas de titre.
C'est une introduction générale, c'est une introduction. C'est présenter ce que vous avez fait, donc le nom de votre manuscrit, ce qui n'a pas été fait. Donc, c'est incomplète. Donc, il faut gérer l'introduction. Le contenu, c'est vrai que l'introduction générale, vous le contenu, donc il est incomplet. Parce que normalement, vous devrez présenter donc
la problématique.
Ça, c'est la prise en charge.
Donc, elle est incomplète. À refaire. Là, pour l'instant, le résumé, on va faire parce qu'il y a des bons minutes de résumé. Donc, il y en a des résumés qui manquent. À la fin, il y aura abstrait. Donc, ce qui manque. D'accord?
Résumé en
On le rajoute.
On
arabe et en français. Pas de
Donc, je vais essayer de vous en confondre des choses. Là, vous parlez d'une automatisation. Donc, l'automatisation, en quoi consiste l'automatisation?
L'automatisation dans notre projet concerne l'orientation automatique des angles, sachant que les contenus de la
automatisme, automatiquement, donc vous avez parlé, donc vous passez quelques données, donc il y a le retour. Ça dit, il n'y a pas de chaîne un jour, pas de chaîne, donc chaîne d'assainissement, donc automatique aussi de la. Et quand on parle d'automatisation des règles, généralement, ça pose problème donc, de stabilité au système et problème de précision, ce qui n'a pas été fait. Je n'avais pas parlé de ça.
Si on faisait la réalisation, on faisait.
Par exemple, il n'y a pas de boucle. Les boucles,
on limite le travail.
aussi, il y a ce qui manquait dans votre travail. Parce que ça automatisé, donc on commence à se
فصار في التوجيه ما طلعش بالكرياليزي هذا ندير لكم تكون داير
Et quand on fait de l'automatisation, donc automatiquement donc, on doit songer à des boucles de régulation, donc à réguler certains paramètres. Et quand on régule les paramètres, quel est le problème de précision qui va se poser? Problème de stabilité, donc automatiquement on doit penser donc, à un régulateur. Donc maintenant on n'avait pas son. Donc s'il y a des data, pour je ne suis pas contre parce que le temps, les conditions, mais laisse pousser les avantages qu'on doit le signaler. Donc à arriver donc, vers un travail plus ou moins, je ne l'ai pas fait. Donc ce rapprocher, je n'ai pas fait.
Mais selon ce que je sais concernant les moteurs pas à pas, ils n'ont pas besoin d'un retour pour être convaincus, non?
Vous le faites le moteur?
انت كيف عارف بلي لا فالور تاعك هذيك نسمي لا صوت تاعك هذيك كل ما تعايش كل ما دير ريجوليات كل ما دير جدولات لا سي البوزيسيون هو ريجولي البوزيسيون كل شيء doit être précis هنا جو بون ليرور تاع ليرور بيرمانون elle est importante donc le ça dit que le système هذا doit être corrigé qui nous ça fait changement quand je change s'il n'est pas régulé, donc s'il n'est pas corrigé, c'est la caractéristique. Quand je change la système tel, je dois recommander la même caractéristique de ça n'a pas de sens. Même la troisième, ça n'a pas de sens. Puisque le système n'a pas été corrigé pour développer la veille et la formelle. Donc, le système qui va هذه la caractéristique de c'est qu'a fait le changement à la deuxième d'accord, nous sommes dans la troisième. Alors, parce que le système n'a pas été corrigé. Voilà donc, si vous voulez, quelques remarques. Quelle est la qui manquait à votre manuscrit? On est content qu'il nous donne une image bien figurée. Donc, c'est un support, c'est un moyen pour expliquer. Il doit avoir une référence. Ça m'a demandé qu'un bidon, donc je dois la signaler le texte. Ça n'a pas été fait. Quelques schémas, ça a quelques figures signalées, ça a quelques figures non signalées le texte. Sinon, il faut apprendre. Donc il faut revenir vers le schéma, tous les schémas. Où les figures doivent être signalées le texte. Selon le schéma donné. Là, le schéma, voilà le schéma de
il faut les interroger dans le texte.
Ah, il faut les interroger.
Vous n'aurez pas présenté un cahier de charge. Vous n'aurez pas présenté un cahier de charge de votre réalisation. Au moins, avant d'entamer la simulation, vous devez présenter un cahier de charge. Okay. Vous n'aurez pas fait ça. Okay.
لا بصح عندنا في السيميلاسيون هي هذا كاين
Oh, tu n'as pas
Si on parle des actions de la puissance,
هذه متاكد الساعه
Je peux vous transmettre tout ce qui a fait en client. مثلا عندي des textes consommés. Le calcul تاع
لا لا ما نسمعش ايوا
Tu n'as pas compris. La page 31, أنا نشوف ما كاينش ديفيرونس بين الشيما الأولى، الأنتيبيوتر الأولى والأنتيبيوتر الثانية. هذا الشيما تاع القرآن كومبلي، ما فيش لا مخلط في الشيء واش بالنسبة للأولى. دونك لا سي دي تونسيون. هذا هو الشيما ان بروبليم، هو avec les différents courants, les différentes tensions. Donc schéma qui va bien عندوش دور. قال لنا فيش donc ça défaut le complet. Pour terminer, les gars, en conclusion générale, أنا لا كونكلوزيون جينيرال كنبات في الفروض هذه ناقل رعيلة بزاف ناقصة en 2 mots ندير tout un travail et pas toucher les autres à la conclusion générale. Hein? C'est essayer donc de mettre en valeur ce que vous avez fait. Normalement. Les objectifs, on est arrivé donc à réaliser nos objectifs. Les contraintes qu'on avait dessus. Les contraintes qu'on avait, normalement. Donc c'est pour ça que j'ai simplement en 2 mots que mettre le blablabla. Donc il fallait signaler ça. Il fallait signaler. Un petit peu en deux, par la juge, il a fait la guerre, il a fait le mal. Du coup, les filles ont conclu que هذه فلان يصير على شيء parmi les contraintes elle a marine de tutoriel ça je pense hein il faut faire la ندعش هم les conditions de mécanisme de réalisation احنا on avait comme objectif c'est faire une réalisation très bien لا ديرها هنا بعد لي بروبليم ونزيد واش نبروبوزي بالك انا بطبيعه بعد il fallait le dire. Il fallait signaler كل شيء نعم كان سكر la faute est la conclusion à ce que je là-dessus. Donc si tu veux que ton travail soit mis en valeur, donc ils vont te dire en valeur. Avec les résultats, avec les objectifs, avec الحج ورغم
Moi, je tiens à vous dire que our goals were not fulfilled. Mais si were fulfilled, we were fulfilled.
Non, je tiens à vous remercier, je passe directement la parole à mon cadre.
Thank you, Chair. First, I would like to express my thanks to the jury member for accepting to discuss and evaluate this project. And secondly, I would like to express my deep thanks to the students for their efforts and for their efforts for their applicant in this field. Really, the project is initiated or is the project was started in the last year for the contribution of many students of the Faculty of Technology in the rocket competition, which is down in Lida, Wilaya of Lida, and in the competition, I decide to conduct this work or the first one of this work in fact for realization of the launching system in our electrical department. So we decide to realize these projects, and this project initially should be funded by Commande. And due to the limits involved by COVID constraints, we cannot start the realization fast. And our ministry and secondary department was decided to conduct all realization project to simulation. This is what happens in this situation. Yes, but my question to the student: are you started to realize the project, the prototype of project, or not?
Yeah.
Is it here?
No, it is not here.
But yesterday I asked you to
bring it.
Yes.
But you said forget it.
Well done.
No, I didn't actually forget it. I just didn't want to copy complicate things even more with an incompleted realization.
No.
This is a mistake.
It would be very nice to
This
see
is a mistake.
even a small part.
Yeah, it's a small prototype.
This is what we made.
Part of the
That's
realization.
like we should use in the BYG stepper motors.
Can hugely attract the appreciation of the jury members. This is a mistake. Yes. I would like to thank the student in their application for doing this research in English, and they can reach really high level in this English, which is seen in the presentation and also in the. I'd like to announce that hourly rate of 85% of the work is their proper work.
Bon, نحن نسول هذه لا رياليزاسيون في البلاد اللي جبنا نسينا المكان وذاك اليوم يكون امر وحده اليوم ماشي سيميلاسيون غادي يكون امر وحده باسكو لا بروبليم دو بوتي فيها با دو بروبليم في الكورسي تعال نجيو المشاكل طريقه عندكم غادي ما درتوش رياليزاسيون moi je dis à vous les messieurs on va se le filer dans une idée زيدوا معنا
لا هو اللي سويتي.
Donc le jury vous déclare admis. Avec motion, très bien. C'est bon. Ah, il faut essayer de corriger, de le lire.